Okay, so we're starting a new school year here, and I just want to jump into eigenvalues and eigenvectors. We're going to start easy in this video with 2 by 2 matrices. So first off, what is an eigenvalue? Eigenvalues are shown with the variable lambda, which is an upside down y pretty much, essentially. So lambda here is an eigenvalue. So we have an eigenvalue of matrix A if there exists a non-zero solution vector K of the linear system. Okay, so that looks like if we have A times K, it's going to equal lambda times K. In our case, K is the eigenvector, where lambda is the eigenvalue. So to start off how we find this, we need the characteristic equation. Characteristic equation. For linear algebra, our characteristic equation is the determinant of A minus lambda I, and that's equal to 0. So for example, we have a 2 by 2. And just to go over, for our 2 by 2, our identity matrix, which is lambda I, is just 1s across the diagonal. And if we have lambdas, it would just be lambda, because 1 times lambda would be lambda. So for our first example, I'm going to have our matrix be equal to 3, 4, -1, and 7. Excuse me, we need to start off with the fact that the determinant of A minus lambda I needs to be 0. So I'm going to plug in our matrix here. 3 minus lambda, 4, -1, and 7 minus lambda. Let's have those in parentheses. So this needs to equal 0. So I can multiply these, 3 minus lambda. So to get our determinant, it's 3 minus lambda multiplied by 7 minus lambda, and then minus 4 times -1 is going to be equal to 0. So just to show you one trick that I like switching these, putting my variable up front and changing the signs. And this would turn plus, so plus 4 equals 0. So I'm just showing this extra step. Normally I would just run it through. Got lambda squared minus 10 lambda plus 21 plus 4 equals 0. Lambda squared minus 10 lambda plus 25 is equal to 0. So in our case here, that would be lambda minus 5 squared is equal to 0, showing that in this case lambda 1 equals lambda 2, which is 5. So lambda equals 5 has a multiplicity of 2. Our next step is we would plug this in. So this is our example that we're using. I'm going to plug it into our matrix. 3 minus 5, 4, -1, then 7 minus 5. That's going to be equal to 3 minus 5 is -2. Then we have 4, -1, and 2. So we're going to set this equal to 0. So I have -2. You could do x1 or k1. For me, it's just cleaner to do x's, so I'm just going to have that. Plus 4x2 is equal to 0. I'm going to set them equal to each other here, so bring this to the other side. 2x1 is equal to 4x2. Great. So Let's simplify it. Divide by 2. x1 equals 2x2. So if I set x2 equal to 1, this is where you can kind of pick. I'm setting x2 equal to 1. Well, that would mean that x1 equals 2 times 1, which is 2. So when lambda 1 is equal to lambda 2, which is equal to 5, my k solution is 2, 1. So let's jump back to this that we had, right? Where is it? AK is equal to lambda k. Let's check that out. Scrolling down here, let's rewrite that. AK is equal to lambda k. So I have my matrix A, which is 3, 4, -1, and 7. My solution K is 2, 1. That's equal to, in our case, lambda is 5 times K, 2, 1. So that's my scalar here in this case. So doing vector multiplication, 3 times 2 is 6, plus 4 times 1, which is 4. And then I have -1 times 2, which is -2. 7 times 1, which is plus 7. That's going to equal to my 2 by 1 of 10 and 5. Lo and behold, that's equal to 10 and 5. So that is a solution. Alright, so that was one example. Let's run through another one really quickly. So my new matrix here, matrix A again, it's going to be -1, 2, -7, and 8. We start off A minus lambda I. The determinant, or characteristic equation, A minus lambda I is equal to 0. So I'm going to have -1 minus lambda. I'm going to have 2, or -7, untouched, and then 8 minus lambda. And I know that has to equal to 0, so let's do our determinant multiplication here. So we're going to have lambda plus 1. I'm just switching the signs already. Multiplied by lambda minus 8 minus 2 times -7. It's got to equal to 0. So this right here, lambda squared minus 7 lambda minus 8. And then this turns into a plus 14 equals 0. Simplifying, lambda squared minus 7 lambda plus 4, 5, 6 equal to 0. Lambda minus 6, lambda minus 1 equals to 0. So I'm going to start off with lambda 1 equals 6, lambda 2 equals 2. Let's keep that. So lambda 1 is equal to 6, it will start off with. Plugging that into my matrix, -1 minus 6, -7, 2, 8 minus 6. That's going to simplify into, where is that? Okay, -7, 2, -7, and -2. So I know this has to equal to 0, so let's do that. So -7 again, x1 plus 2x2 equal to 0. I'll set them up equal to each other. So 7x1 equals 2x2. So in this case, you could pick any number. I'm going to pick that x1 is equal to 2. So if I set x1 equal to 2, what do I get? 7 times 2, which is 14, equals 2x2. So that means that x2 is equal to 7. So my k1 would be 2 and 7. Let's plug in our other guy now. So let's go check now. Let's say ak is equal to lambda k. So zoom out a little more. So a, in this case, -1, 2, -7, and 8. My k vector here is 2 and 7 is equal to my lambda of 6 times k, which is 2 and 7. So doing our matrix multiplication, it's going to be so this is a 2 by 2, this is a 2 by 1, so I'm going to be left with a, I'm going to be left with a 2 by 1. 2 by 2, there you go. Okay, so here's my 2 by 1, jump down a little bit. So -1 times 2 is -2, 2 times 7 is plus 14, -7 times 2 is minus 14, 8 times 7, 56. And then on this side, 6 times 2 is 12, 6 times 7, 42. Is that true? Yes, it is. This guy would be 12, and then this would be 42. Awesome. So that was our k1. Just to get our k2 real quick, I need lambda 2 is equal to 1. So that would be -1 minus 1. I have 2, -7, and 8 minus 1. So my matrix would be -2 and 2, and -7 and 7. Again, -2x1 plus 2x2 is equal to 0. Set them equal x1 equals x2. And I guess we have 2 still. You could divide them out. x1 equals x2. Pretty simple case. You could say if x1 equals 1, x2 equals 1. So my second solution vector would be 1, 1. And we'll stop there. Thanks for watching the video.